All right, here we go. Okay, one thing, we got some low E in this building. I'll admit it, low E. It's 6:47, 6:50 on a Tuesday night. Got Christmas tree in the Christmas tree in the background, right there. Okay, I don't know what that little tree is. She put that little. Where's it at? It's opposite. Oh, I can't fish that way. What about this? Boom, that little tree right there. I don't know what that is. I don't know. It looks like Charlie Brown's Christmas tree. Not my idea. I put up that big tree, and that's her little tree. I don't know what that little tree is. It's like sad little tree. All right, so ask your parents why this song makes sense. I don't even know if you guys can hear me. Can you guys hear me? I don't know. It's off the rails already, and we're only 1 minute into this. Good start. Okay, that's Inner Sandman. That song. Ask your parents. Great song. Okay, a couple things I want to get off my chest. I hope you had a happy Thanksgiving. Hope you ate a lot of turkey, watched a lot of football. Wasn't around too many people, but who knows? Okay, that's the time we live in. I also want to go over some Schoology things, right? We have a couple new eyes in the class. So right now you should be looking at my screen. We have a couple new eyes as far as new students. Okay, and this front page is like your Twitter feed, right? It's how I talk to you guys. It's the only way I can besides this. Okay, so the only way I can talk to you guys is by using one of the updates or sending Schoology messages or something along those lines. Hopefully I don't have to email your parents. Okay? I don't want to email your parents. Trust me, I want to talk to you guys, not your parents. Okay, so this is where you find everything. So here's your updates for this week. Posted them today. If you want to get to the class, you get courses. You go to 2A. This is me as a kid. Just kidding. If everybody knows that movie, that's awesome. Okay, if you message me watching this video and you message me what movie is this from, I'll give you 1 extra point on your homework, one of them this week. Okay, I'll give you a 5 out of 4. That's for anybody. Not first come, first serve. That's for anybody. What movie is this from? Okay. If you watch the video and tell me, take the time to do that, you deserve an extra point. All right, so here's chapter 1, chapter 2, chapter 3, chapter 4, part 1 folders, right? So cool. We want to click chapter 4, part 1 folder, this red one, reddish pink. I don't really know. I'm bad with colors. Okay, if I want to get to my chapter 4 outline, I click chapter 4 outline. Ooh. Okay. I go to my chapter 4 outline. I see the date. I need the date of the lesson, what topic we're doing right here, and then we also have the assignment and reminders. Okay. So there should be no excuses that you guys cannot find where the homework is or what the homework is. Okay, we don't have a packet, so it makes me a little bit nervous for you guys because it gives you an excuse not to do stuff even more. But that's why I'm making this video. Okay, blank notes. If you want to print out your own packet, you go to this blank notes, you click on one of these Word docs, you download it, print it. Okay, then you staple it. There's your own packet if you want one. Okay, I also have some up at the school. If you want to message me, I can set one up for the front desk to have you guys come pick it up. You got to message me about that. Okay, if you want the filled in notes, so here we go. Filled in notes. I already posted them. Part 1 or point 1, 4.1. This is page 1. I had to do it as a picture because I want all these pretty colors. Okay, so I did it as a picture. Here's the first page. Nice, pretty. I took a lot of time to make this. Nice and pretty. And I don't know about that word problem. We'll see. We'll see how good of a mood I'm in. Once again, chapter 4. If you want to get to the video notes, like this will be posted in that yellow folder. Okay, this pink folder is for your homework. You click on the homework. Here's a section. Here's the page and numbers and the show sketches that I never get from you guys. Okay, so should be no excuses here. Nice and organized for you. Nice and pretty. I don't want to hear your parents telling me you can't find anything. I don't know what to tell you. You can figure out a Twitter and Instagram all you want, Snapchat, but you can't figure out a Schoology. Come on. That excuse is old and lame. Okay. All right, so let's jump into it. So we just got done with chapter 3, right? Was it chapter 3? I think so. Chapter 3, yeah, quadratics. So we just got done with quadratics. Okay, quadratics are a type of polynomial, but now in chapter 4, we're going to get into actual polynomials. Okay, I want to stop share. I should be getting into this, right? I'm getting into it. I'm good at it. All right, share screen. Boom. I want to share that screen. And there we go. Okay, beautiful. Put myself in the top right here. And there we go. Okay, so if I want to graph polynomials, or look at the graphs, or look at the type, degree, the name, we'll get into all that, right? Okay, here's the deal. So how we need to figure out, just by looking at the formula, what degree it is, what type it is, it's pretty simple, right? We look at the highest power of x, okay? So, for example, if I have a linear function, we've all done this, at degree 1. The degree, what that means, it's the highest power. Okay? So the highest power is 1. It's a linear function. Remember, there's an imaginary 1 right there. Okay? There's an example over on the right. Okay, next one is quadratic. Highest power of 2, right? There's a 2 highest power. That's the degree. That's a quadratic function. You should know those. If you don't, we got bigger problems. Okay, a cubic is the highest power to the 3rd, right? You see this little 3? Okay, that's the highest power. That's how we identify what kind of function it is. It doesn't matter about the 2. It doesn't matter about the 1. The highest power is 3 in that problem. Okay, quartic is going to be cuatro, quartic. If you know Spanish, that should make sense. This 4 gives it away, and that also gives us our degree. Okay, we'll get more into that in a second, but that's just basic. That's basic types of polynomials. That's how you figure out what name it is. These could be scrambled up in all different orders. Okay, but here's the deal. It's another thing we need to talk about. Okay, standard form. It's important. All these are in standard form. Okay, what standard form means is you take the highest exponent in your equation from left to right. Standard form is always left to right, and then you move it to lowest as you go more right. For example, let's look at a quadratic, since you guys are familiar with that. Highest power is 2, that goes farthest left. The second one is going to be 1, it goes more to the right. One more is a constant, which that's actually 0. Okay, let's go to cubic. Cubic, highest power is 3, 2, 1, blast off. Okay, we should understand standard form. If the polynomial is not in standard form, I would put it in standard form first, so you don't get confused. Okay, and I'll do that right here. Okay, 1, 2, 3, and 4. Am I going to do all of them? Sure, why not? We got time. Okay, decide whether the function is a polynomial function. Okay, if it is not a polynomial function, here's the only couple cases, I guess. Okay, I'll just jump right into it. This, number 2, is not a polynomial function. Why? It's got the x in the denominator. Okay, x in denominator means it has a negative exponent. Remember, if it has a negative little exponent up top, we flip it, put it on the bottom, make it positive. Okay, if x is in the denominator, or if x is negative, which those two are the same thing, okay, then it is not a polynomial. Wow, look at that spelling right there. Good handwriting. The best. Okay, so number 1. First things first, let's decide, is it in standard form or not, right? Is the highest power the furthest left? No, right? The highest power is 4 in this problem. Okay, so we know, you just told me, right? We know, or I just told myself, you just told me, whatever. Okay, the degree is going to be 4. How do we know that? It's because 4 is the highest power. Okay, I want to write this in standard form. S dot F dot, stand for standard form. Okay, so let's put the highest power furthest left, and let's move right. So we have plus 2x squared is the next one. There's no 3. Plus 6x plus 1. Okay, standard form. Done. Okay, no big deal. All right, it is a polynomial. Why is it a polynomial? Because it doesn't have a negative exponent or a fraction where the exponent's in the denominator. Okay, what is its type? Okay, the highest power is 4, so I just told you, right? Quattro, quartic, you'll never forget that. Say that a million times. Quartic, that's the type of function we're dealing with, polynomial. Okay, and the leading coefficient, what does a leading coefficient mean? It means literally what it sounds like, lead dog. Think like sled dog, like, what's that one sled dog movie that I loved? Balto. Oh, go watch Balto. Inspirational right there. Absolutely inspirational. Okay. The lead dog in our sled pack here, our own little Algebra 2A sled pack, is that -3, right? That -3 is our leading coefficient. It's the first coefficient we see. So my LC, my leading coefficient, is going to be -3. Are we done? Is that good? It's good. Cool. All right, let's move on. Number 3. We already did number 2, right? It's not a polynomial. Those ones are easy. All right, number 3. What's the highest power? What's the highest degree? The highest degree is going to be uno. It's going to be 1. Okay, why is it going to be 1? Well, so we only have one x, right? And it doesn't have a number on it, so it's imaginary 1. We don't usually write. Standard form, it's already in standard form, right? It has, you have an x to the first, and then you have a constant. That is highest power furthest on the left. What's the type? The type is linear because my degree is 1. Am I pulling this out of my head? No, you guys are going to pull anything out of your head right now. You're going to pull it right from this chart. My degree is 1. It's going to be linear. Okay. So my type, I guess I could just write it. I'm saying it, right? Save space. It's going to be linear. And my leading coefficient, is this still a number? Yeah, it's still a number, right? Don't tell me it's not a polynomial because that looks all crazy. No, it's still a number, right? My leading coefficient is the square root of 15. No big deal. Okay, I don't know what that voice was I just did. Oh, well. Yes, it is a polynomial, by the way. Questions? I can't see you guys. All right. Number 4. Here's a hint. It's not in standard form. Okay, so standard form is going to be my highest power of 2, and needs to go first. So we have -2x squared plus 3x minus 2 and root 3. Okay, what's the degree? The degree is going to be 2. Why is it 2? Because 2 is the highest power. Okay, what's the type? Don't get this one wrong. Quadratic. Just spent a whole chapter on it. Okay, blood, sweat, and tears on that one. All right, and leading coefficient. Leading coefficient is going to be our -2 right out in front. That's our sled dog. That's our Balto, -2. Okay? Not too bad. What do those things mean? Yeah, we'll get into it, right? Okay, eventually. Probably next page. Yep, right there. All right, so we want to evaluate a function. I'm only going to do one of these to save time, so we're not making a 40-minute video again or an hour-long video. Oh, that was rough. Okay, so when I say evaluate, I've always told you guys, evaluate means we're going to get a number back. We're not simplifying. We're not doing none of that. We're getting a number back, a number value, a numeric value. Okay, I want to evaluate this polynomial at x equals 2. What do you think we're going to do with 2? I don't know. Plug it in, right? We should get one number back. Everywhere we see an x, I'm going to plug in 2. We have negative. Put it in parentheses when you plug in something. Don't forget that. 2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. Okay. What is that? That is h. Not an h. That's an f. Have it. H evaluated at 2. If you want to get fancy and write it like that, go ahead. That's what that means. H evaluated at 2. What number do I get out? Okay. If I was a better teacher, I'd probably do that in my head for you, show you how smart I am, but I'm not. Okay, so I'm going to use a cheater. Okay, so we have -2 parentheses, open parentheses, put 2 in the parentheses. -2, close parentheses, cubed, minus 2 times 4. I can cheat with that one, right? I'm smart. Minus 6. I can cheat with that one too. Plus 4. I got -18. Okay, double check if it's right. So let's see if it's right. Let me just plug it in. If you want to double check yourself, all you got to do is plug in the whole thing again and not try to be smart with it. So we have -2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. That's what I got. -18 twice. Double check twice. -18 is the answer. And voila. I'm not going to do the second one. I don't think it's very hard. You're going to get 0 over here or something like that. Okay, should get 0. All right, that's it. That's done. All you're doing is evaluating. That's the easiest part. It's all calculator. Okay, it's not a whole lot of teaching there. You plug in a number, you get a number out. Cool. Input, output. Don't forget that. All right, now we need to figure out why we did all this stuff, right? Why we labeled degree, put it in standard form, give me the type, what type of polynomial is it, and leading coefficient. It actually means something, right? So what it means, it actually tells you how the graph is shaped. Now it's going to tell you each individual points. No, you got to plug points in to get that. Do we really want that? No, right? Okay, what it's going to tell you is something called end behavior. So end behavior, what does that mean? That means what do the arrows do? The left one, what does it do? So on this one over here, the left arrow, and this is how I want you guys to write it. The left arrow goes down, right? Towards negative infinity. And I hate to be this simple with it, but you can give me negative infinity, but if you give me down in a 2A class, hey, I know it's negative infinity, right? If we want to look at the right arrow, I'm looking at this top left box right here, this top one. Okay, it is going up. That is end behavior. On this one, it's opposite, right? The left arrow is going up. The right arrow is going down. Once again, hate to be simple. I don't want to oversimplify this. Okay, I'm going to end up with a college professor in my YouTube comments. Okay, left up. What does up mean? The arrow is pointing towards positive infinity. Okay, if it's going right down, then that's how you know it's going towards negative. Well, as far as the y values. Okay, as far as the y values, negative infinity. Cool. The y values are our output. That's why we're dealing with the y values. Everybody okay with that? Left up, up means positive infinity. I gotta at least mention that. Okay, down here, they both are up and up. Okay, and these both are down and down. Okay, but we know automatically what the end behavior is just by looking at the degree and the leading coefficient. Okay, so on these next two, or three, I guess, we're going to look at what degree is it? Is it odd or even? Okay, and then we're going to match it to one of the boxes. And then is the leading coefficient positive or negative? So you're looking at those two things, degree and leading coefficient. All right, so number 7. What's the highest power of number 7? That's where we all say 6. Yeah, good job, guys. Okay, our degree is going to be 6. Is 6 odd or even? Even. So we know we're going to be where in these boxes here? We're going to be in the bottom two, right? Okay, either one of those. Now we got to look at the leading coefficient. Is this in standard form? Yes, it is. How do you know? Because the highest power is left. The second highest power is the one directly to the right, third and fourth, and so on, right? So is the leading coefficient going to be negative or positive? Where our leading slag dog, our Balto, right? Great movie. Once again, go watch it. Our leading coefficient is -3. Obviously, it's going to be negative. Okay, so what box am I looking at? I'm looking at this box right here. Okay, we have an even degree, and we have a negative leading coefficient. Okay, so all I'm looking for is the end behavior. That's all I want you guys to tell me. So what's the end behavior? Left up, positive infinity, right up, positive infinity. Just give me up and down. Don't get into positive infinity stuff. Okay, that's all I want you guys to understand. All right, so number 8, let's put it into standard form first. Okay, so standard form is the highest power, right, is going to be our farthest left one. So our highest power in this one, our degree is going to be 5. What type of function is that? Scroll up. Kintic. Oh, this one doesn't have it. 5 is called a, ooh, what's the spelling? Kintic. Okay. All right, so our highest power is 5. I want to write in standard form. Put that first. Okay, so we have 3x to the 5th. Second highest is going to be that 3, negative 3x to the third cubed. No squared, so just put the x's together. You could go ahead and add that out, but for this problem, we don't really need to. Okay, so my degree is 5. It's a Kintic. My leading coefficient is 3. Okay, is that going to be positive or negative? That leading coefficient is positive. Is my degree odd or even? It is odd. Okay, so I know I'm going to look at these top two boxes. And for this problem, we're going to be degree is odd, a positive leading coefficient. So here we are, the top left box. Okay, so my in behavior, my two arrows, it's going to be left down, right? Right here, it's going to be left down, right up. Okay, left down towards negative infinity. Right is going towards positive infinity and beyond. Buzz Lightyear. Okay, cool. All right, I'm not even going to do number 9. Come on. Just look at the arrows. The left one's going up. The right one's going down. It's all at once. Okay, number 10, graph the polynomial. I'm not going to spend a lot of time on it. You're literally going to plug it into Desmos. If you guys don't know what Desmos is, I will show you real quick. It is awesome. Okay, so if I want to go to Desmos, all I got to do is, well, let's keep this up. Let's stop share. I'll go full screen again so you can see my ugly mug. Let's go to, and this is good for the new kids. Okay, let's go to share screen. Let's go back to Schoology. Oh, where do I have Desmos in? I have Desmos in my materials section. Click on Desmos. Watch this. Okay, it already opens up. It's I'm going to take you to another website. What's our function? 16 minus x to the 4th. What degree is it? It's a quartic. Okay. What's the in behavior? Down, down. I'm assuming you guys will get good at that. But let's graph it and see just in case. Okay, here's what my graph looks like. Kind of funky. It looks like a funky looking quadratic, right? Just like with a little flat here. We'll talk about that later. Okay, this is cool stuff. This is my nerd stuff I like talking about all the time. All right, so here's what we're going to do. Do you guys think I'm going to go through and be super particular with my drawing, my graph? If you say yes, you obviously don't know me as a teacher. Okay, no, here's what I'm going to do. Let me go back to my little OneNote thing over here. Okay, here's my beautiful sketch I'm about to make. Okay, here's my beautiful XY axis. I need to go up to 16. I don't have 16 boxes here, so what am I going to do? Well, we'll just call that one 16. Okay, and my graph looks something like this and something like this. What do I really care about? I care about those two arrows. Are they pointing in the right direction? They're going down and down. All right, that's a sketch. That is a sketch. I repeat, a sketch. Okay, obviously mine looks like, well, crap, right? It's okay. It's a sketch. I got the gist. I know that you did graph it. That's all I'm looking for in your homework. So you don't have to spend hours making T-charts and all that nonsense. All right, number 11, I'm not going to do. It's the same process. Plug it in Desmos, sketch it, done, move on. Okay? All right. So let's scroll down. Describe the x values for which f is increasing, decreasing, positive, or negative. Okay, this takes a little bit of thinking. This is the first time we're going to think today. All right, look. So let me just label all 4. Let's start like this so we can get our brains going. Increasing, decreasing, positive, and negative. All right, remember, I'm looking for interval notation, right? I'm looking for just talking the x values, right? So we're just on the x-axis. We're just moving left to right. Where is this function increasing? Okay, so this function does not give you the vertex. It's kind of my pet peeve with it. This graph doesn't. I'm just going to give you the vertex. It's halfway in between. The graph goes by 2's. So the x value is going to be 3, and the y value is going to be -1. Okay, I just want to give you that right off the bat so you don't have to find it. Okay, so where does this function increase? So remember, like let's say I put, I don't know, who's actually going to watch this? Who'd actually watch this? I don't know, I bet Skylar does. Let's put Skylar right here. Let's put Skylar on a ski slope. There you go, Skylar. Beautiful drawing. Some luscious hair flowing in the breeze. Okay, Skylar's going skiing, right? She's going uphill, right? That is increasing. So from what x value does Skylar start to increase? Well, we already know how to do this. We already talked about it. It's the vertex, right? The x value of the vertex. So it's going to be my 3. Now, where is she going? She's going up, right? She's that in behavior, that arrow is pointing up towards the right. Okay, so we're going to positive infinity. Okay. Now, if I throw Skylar on the left side of the graph, I'm not going to do it because I'm a terrible drawer. You guys know this. Where is she going to be coming from? She's going to be coming from this negative land, right? So this negative land is called negative infinity. What x value is she going to stop to decrease? At the bottom, the exact minimum, right? That's what the vertex is. It's going to be the x value of 3. All right? Okay, it's very, very simple. Increasing, decreasing. We have already gone over this. You guys should remember it. Just a review, though. Second thing I want to cover, positive and negative. What does positive and negative mean? That means, actually, let me switch colors here. So this is the thinking part that worries me. Let's make positive green and negative blue. Okay, so let's just look at positive. Where is my graph? Where is the outputs going to be positive? Well, how can we tell that? We can tell that by just looking at the y values, right? This is going to be positive land, anything above the x-axis, and this is going to be negative land. Okay, so from what x values, and it's going to be a set, right? It's going to be 2 different ones. From what x values is my graph positive? Where is it above the x-axis? Okay, so we have this little section. Let me get this out of there. This little section right here. That's above the x-axis. But we also have another one, right? We have this little section right there. Okay? Well, we can do that, no problem. No problems at all. What x values, okay, and this is going to be 2. What x value is that far left land? Well, we just did it, right? We did negative infinity. That's coming from negative infinity to what x value? Well, 2. Okay, and then we also have the little union symbol, right? You got 2 different intervals. We have from 4, right here, right there, 4 to positive land. So it's going to be positive infinity. Okay, so positive's done. Let's go to negative. For what 2 x values is this graph? What interval is this graph going to be negative below the x-axis? Well, it's going to be right here. Just that part, right? So just that part is just 2. Let's put those in brackets if you want to be picky. 2 to 4. Okay, that's below the x-axis. All right, nah, I'll leave them in parentheses just not to confuse you guys. Boom. 2 to 4, just the x values. 2 to 4, it's an interval. Okay, it's like, I don't know, Google Maps. Interval tells you where your maps is going. Okay, bad analogy, but it's the best I can come up with. That's interval notation. If you need help with that, you got to message me. I'll help you, I promise. Okay, it's just thinking. Thinking's hard for us, I know. Okay, it's hard for me too, trust me. All right, so here's what we want to do. Let's look at this word problem. Okay, the number of students, S in thousands, who graduate in 4 years from university. Hard to do, depending on your major. Okay, from university can be modeled by the function S of t equals negative 1/4 t cubed plus t squared plus 23, where t is the number of years since 2010. Okay, using a graphing calculator to graph the function for the intervals 0 to 5, right? T's in between, included. Both those are included. Describe the behavior of the graph on this interval. Okay, so I think I'm only going to do A. B's kind of finicky to me. All right, B's one of those where Max would, 4th hour Max would get on me about. He'd be like, can't you do it this way? And I'll be like, yeah, you probably could. Okay. All right, so little letter A. So let's use it, right? Let's use a graphing calculator. Sounds complicated. It's not. What are we going to use? We're going to use Desmos. Why did I flip this again? I can just stop sharing my screen. I'll go full picture. See my ugly mug again, and then I'll share the screen I want to share. I'm getting good at this. Okay. All right, so we want to type this function into Desmos. We totally can. So we have negative 1/4, 7, not 4, x, I'm just going to use x. Why am I using x? Because it's a pet peeve. Can you use any variable? Yes. T squared plus 23. Okay, let's zoom out so we can see it. Oh, add slider T. Oh, geez. See, I did what I said I wasn't going to do. It's pet peeve. Okay, so here we go. This is my graph. This is the graph I just created, right? Okay, where am I looking at it? I'm looking at it from the x values or t values. I'm looking at it from 0. So let's move the graph to 5. Okay, so from here to here. Okay, so let's describe the end behavior. If I put imaginary arrows on right here, if I put an arrow right there, where's that going? That's going down, right? If I put an arrow going here, all the way to, well, this one's going to go down too, to 5. So it'd be right here. Now let's see if I can get it exact. Oh, I'm good. It's at the gas pump. Okay, so that's 5, 0 to 5, right? What are my two end behaviors doing? Well, they're both going down. Okay, my left one's going down and my right one's going down. Okay, we good? If you want to do a little sketch, you can, but that's pretty much how you do it. That's the end behavior. That's all you're looking for. Okay, is it positive? That's another thing we can look for. Well, is it from this interval? Is it above the x-axis? Well, yeah, the x-axis is right down here. It is positive. Now, if you make a different interval, down here is going to be negative, right? But that interval is positive. Okay? All right. That's pretty much it. Do you think this model can be used for years before 2010 or after 2015? Explain your reasoning. If somebody shoots me a message, it gives me a good answer, I'll think of throwing you a bonus point. Why not? Who cares? Okay, use your brains. I like when you use your brains. All right, hopefully that wasn't an hour long. I'm trying to limit these. It's just a lot of talking. Okay, it's a lot of talking, especially during remote learning. I'm trying to cover 2 things in one, pretty much. All right, guys, have a good one. You'll see me again on Thursday or Friday as far as the video-wise. I will post this for you. Please watch it. If you want to like my YouTube video so more people can see it, or subscribe so you don't have to go to school every time I upload, sure, do that. Okay, I sound like one of those YouTube guys. Like and subscribe, bro. Nah. Okay. All right. See you guys. Peace.